Hello everyone, my name is Arun, and today in this video, I am going to present you Resque, which is a real-time, event-driven emergency triage and logistics orchestration platform which is powered by multi-agent AI, spatial computing, and streaming infrastructure. So Rescue is basically a distributed emergency triage and logistic orchestration system which is designed to process the incoming SOS signals in real time and route them through an AI-driven decision pipeline. The system injects structured binary emergency packet, evaluates the urgency using a LLM-based triage agent, and allocates optimal resource reports via vector similarity search and computes safe routes using spatial queries. So this is the overall description of the project that we have. So the system integrates a lot of backend primitives that we have, including Kafka, Qdrant, PostGIS that we have. We will look further about the engineering tech stack that we have used a little later in the video. But for now, the front-end dashboard is built using Next.js, and it uses WebSocket under the hood for real-time data communication with the help of all the incoming payload that we have. So the primary engineering goal that we had over here was to build a resilient, fault-tolerant emergency dispatch pipeline, which was capable of handling partial system failures, rerouting logistics dynamically, and ensuring safe spatial decision-making under constraint. Now let's talk about the application user interface. So this is the entire application user interface that we have. So this is the sign-in page or the sign-up page that we have. Obviously, during a catastrophe and during a disaster, it is not possible to, have a sign-in kind of a thing at that particular moment because there might be no network, right? And this entire application is basically designed for P2B, peer-to-peer network, transmitting of the events payload via P2P mechanism that we have. So obviously this is one-time thing, and obviously this is very mandatory to get the to get to know about the personal information of the user. Then in the welcome screen we can see that welcome and my name, and basically we have a field transmission box over here wherein we can use a situation report to write about a situation in short, and we can also use this local microphone kind of a thing which does not utilize the internet and can convert whatever the user speaks to the mic into the text over here itself. And in order to get more idea about the situation, basically, majorly the situation type can be broken into four of the things. One is medical, one is rescue, one is supplies, and one is safety and hazard. So the user might choose any one of them, and it is very helpful to compute the similarity or the urgency score that we have that the LLMs will later on compute for. And then we can deploy SOS, and in the timeline thing, we can have this entire thing. For example, this is one of the SOS that I've sent, like, hi, I need emergency help. My grandpa is sick, for example. So this will be computed from one device to another node, and till that part, till we find one node or we will deploy some drone units until that one particular unit can transmit via the network to the backend service station that we have, and from there LLMs can infer the payload and understand and rate it and showcase it to a person or a supervisor who is looking at the next year's dashboard screen that we have to get an idea about the entire thing. Okay. So let's now talk about the tech stack that we have. So for the API layer, we are using Fast API. For the streaming, we are using Kafka. For orchestration, we are using LangGraph, and LLMs, we are using the API here provided by Gemini. The vector DB we are using is Qdrant. The embeddings is mini LM embeddings that we're using. And the spatial DB we are using is PostGIS basically. And the backend runtime is written in Python, and the backend dashboard is written in Next.js that we have. And we are using authentication using Firebase, and that is a one kind of a thing. I know that it's not possible to do it again and again. So yeah, that's one kind of a thing. Okay, now let's talk about the system architecture that we have. Okay. So we can see that this is a drone unit or a field node that is able to connect to the backend service. I know there will be a lot of P2P hoppings that I have not shown over here, but obviously there will be a lot of P2P hoppings that there will be that would take place. And once a field node or the drone will get that payload, it can post it to the API fast API edge gateway that we have. So basically, initially, that this is kind of a initial process. The Firebase authentication is one kind of a process, like it is not required again and again, but it is initially it is required. And then the fast API Edge Gateway can use Kafka event stream to publish it to the LangGraph agent, wherein the all the agents that we have will talk to each other, collaborate with each other, produce structured logs, will write a lot of things to the vector databases to fetch it quickly and to maintain the sentence and to semantic information kind of a thing. And basically, from the backend things, we can also put in a lot of information about the, for example, the amount of drone that is deployed or the real-time drone information that we have that can also be there, and the emergency kit or the emergency loot or the amount of things that we have for emergency things and the coordinates for them that can also be showed, and everything the LLM can take the information, it can use the vector databases. A lot of rule based matching is also there. So it can automatically use that and mark the urgency score and show it to the and show it back to the the Kafka, and from the Kafka the WebSocket will through the gateway, everything will be updated to the command dashboard center, wherein the supervisor can look at it and have a good idea about like how everything is managing, like what is the best route, what is the best path. So this is the overall architecture that we have of the entire thing. And obviously there is Prometheus and Grafana also for the metrics and the dashboards kind of a thing for maintaining of the entire thing. So that is also there. Okay. So now again, engineering decisions that we have. So why did I choose one particular thing for this architecture over the other things? That is also very important. So this project took me like a good amount of time to make, like everything I designed, I thought like why is it better over the other things and everything. And like I've used Protobuf also over here over the other REST API things because I want payload size as minimal as possible. So a lot of engineering things I have thought about and designed over a long period of time, and then only I made this application. So yeah, everything I've written over like this is a LangGraph multi-agent pipeline. We are using Kafka for a lot because in disaster there might be a lot of ingestion of the SOS payload that we have. Then we have Protobuf to minimize the payload size. Then we have Qdrant vector databases to get an idea about the semantic retrieval kind of things. The mini LM for embedding model, that PostGIS, then we are using Docker and fast API gateway. So everything I've written here, like why have we discussed, but more or less we have discussed everything in the high HLD or the high level design part only. So yeah, this is everything about the rescue application that we have. So again, rescue is a distributed emergency triage and logistic orchestration system, which is designed to process the incoming SOS signal in real time and route them through a AI-driven decision pipeline. So yeah, thank you for this. Thank you for watching this video. And if anybody is interested to read more about the entire architecture and everything of Resque application, they can visit my GitHub profile. And in this rescue repository that I have, they can read the README file. Okay, thank you.